In this video, we're going to look at Lewis symbols for atoms and ions. So what is a Lewis symbol? This essentially describes the valence electron configurations around an atom or an ion that happens to be monoatomic. Before we can do this, we do need to review electron configuration in order to be able to draw a Lewis symbol of an atom or ion. So let's try the electron configuration of the element nitrogen. Nitrogen has 7 electrons in the neutral atom. And to the right-hand side of my nitrogen symbol, I have the orbital diagram drawn. And we're going to place our 7 electrons in our orbital diagram like so. And to determine what our electron configuration is from that, we write the symbol for the shell and subshell plus the number of electrons in all of the orbitals within that subshell. So for the electron configuration of nitrogen, that is 1s, 2, 2s, 2, 2p, 3. Now, when we draw the symbol, the Lewis symbol of the nitrogen atom, what we'll do is draw the symbol of the element, and then we determine the number of electrons out of our electron configuration that are considered what we call valence electrons. The valence electrons are the number of electrons or total electrons in the outer shell. And so the outer shell in this particular element happens to be n equals 2. And so we'll take all the s and p subshells, add them together with all the electrons in all the orbitals, and that's the number of valence electrons. So this is 2 plus 3, and that gives us a value of 5 valence electrons. And we're going to place those valence electrons in a pattern that is indicative of the orbital diagram. We can only place electrons to begin with in our Lewis symbol for atoms and ions in a location that's on the left, the right, the top, or bottom of that symbol. And we place them in a way that we can either do paired electrons or unpaired electrons. So these are our two options of placing those electrons. Each time you have a set of electrons where there are 2 within a single orbital, this is considered a paired set. When you have electrons that are in an orbital by themselves, you have 3 of those in the 2p subshell, these are considered unpaired. That paired and unpaired pattern must be represented in the Lewis symbol. So what we're going to do is place them. I'm going to start with the 2s subshell and put those 2 electrons paired together in one of the 4 possible locations. It does not matter which one you choose, just as long as it's any one of those 4. And then I'm going to place the other 3 electrons in an unpaired pattern. So I'll put 1, 2, and 3. Total 5 valence electrons. There's one set that's paired, 3 electrons that are unpaired, and this is the Lewis symbol for a neutral nitrogen atom. So let's review those particular items that you need to have to draw a Lewis symbol. First, you need to determine the electron configuration, and you'll use an orbital diagram to do this, so you'll have that also as well. You need to determine the number of valence electrons. So we've got electron configuration, the valence electrons within that electron configuration. Those are going to be the dots that you're going to place around the element symbol itself, and it's going to be the same number of valence electrons as dots. And if it happens to be an ion, you just include the charge with the total number of valence electrons. For instance, if you have an atom like sodium and it happens to have a +1 charge, normally you would figure out from the orbital diagram and electron configuration that there is 1 valence electron in neutral sodium But since it's a +1 charge, you're going to subtract that +1 from the value of valence electrons. So this will tell us there are 0 valence electrons, and it will have a plus charge. That value, these guys right here, will be what you use in order to draw the symbol. So let's do some examples of where we do normal neutral atoms and charged atoms so that we can practice drawing our Lewis symbols. So aluminum. Aluminum happens to have 13 electrons, and so its orbital diagram looks something like this. 1s, 2s, 2p, 3s, and then 3p. And so you place the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 electrons within that orbital diagram. So this gives us our electron configuration to be 1s2, 2s2, 2p6, 3s2, 3p1. The last shell is going to be the third shell. So this is shell n equals 3. And there's a total of 2 plus 1 electrons. This is going to give us 3 valence electrons. So let's draw the symbol for aluminum. And then let's place our 3 valence electrons in a pattern that is indicative of the pattern that we see in the orbital diagram. So you'll have a pair that is of electrons that are paired, and you'll have 1 electron unpaired. So this is the Lewis symbol for aluminum. Let's try this now with chlorine. So we'll use our orbital diagram again. And you guys will get very used to drawing this orbital diagram. And so you'll remember, based on the Aufbau principle, the filling order of your subshells. And so chlorine has a total of 17 electrons. So let's place those 17 electrons into our orbital diagram. That's a total of 10. Then you have 12, 13, 14, 15, 16, 17. And so from our electron configuration, you have an electron configuration that looks like such, where, oh, I'm sorry, that should be 5, where the last shell, again, is the n equals 3. So we sum up the total of all of those electrons, 2 and 5. That's going to give you 7 valence electrons. And so when we draw the symbol, the Lewis symbol for chlorine, we have chlorine, and then we're going to place 7 electrons in dots around chlorine, but make sure that we're using the pattern that is indicated in our orbital diagram. There are going to be 3 sets of paired electrons and 1 unpaired electron. So I'm going to draw it to look something like this. That is the Lewis symbol for a neutral atom of chlorine. Let's try sulfur 2-. So one thing that we need to figure out is how many electrons does sulfur 2- have? Well, sulfur in a neutral form has a total of 16 electrons. Let me write that. 16 electrons. But since we have a -2, we're going to add 2 to that. So it's a total of 18 electrons in total. So when we draw our orbital diagram, it will look something like so. And we'll place all of our 18 electrons within our orbital diagram. And it turns out that will completely fill the 3p subshell. These are all of the valence electrons, and that number ends up being 8. Okay, so when we draw from our orbital diagram, or we could use our orbital diagram to go ahead and draw our symbol, or you can write the electron configuration as well to do this, but I'm just going to go from our orbital diagram. Essentially, you'll have sulfur, the symbol. You're going to place all 8 of our dots in our 4 possible quadrants. They're all paired, so you notice this is paired, 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 and paired. But it's an ion. So I do have to put, with the Lewis symbol, the charge. So I'll put 2 minus. That is how you draw the Lewis symbol for an ion. And let's do one more example. Magnesium 2 plus. Orbital diagram 1s, 2s, 2p, 3s. Magnesium normally has, in a neutral atom, it has 12 electrons. But since we are at a +2 charge, we're going to subtract 2 from that value. So that's really 10 electrons. So let's place all of our electrons in our orbitals. And that ends up being 10. So remember, we used to have 2 here, and then those were given away. So really, in magnesium 2 plus, we actually have given away what would have been the 2 valence electrons that it had. So how many valence electrons does it have in its outer shell? 0 valence electrons. So we write the symbol magnesium. We don't have dots because the 2 valence electrons were given away. But we do put the symbol charge of 2 plus. That is the Lewis symbol for magnesium 2 plus. In the next video, we're going to look at how to translate doing Lewis symbols into what we call Lewis structures. And so we're going to start combining atoms together and making full compounds and drawing their structures and using the same methodology. I will see you in that video.